In this video, we're going to look at section 1.12, starting on page 70 in your book. So get out a few pages in your book, starting on page 70. In this section, we're just going to look at some different kinds of vocabulary words. Representing a quantity with a letter, word, or name is commonplace in real life and has already been seen in the previous lesson. When we move from a specific number situation to a generalized situation using variables, we move from arithmetic to algebra. And so here's some key vocabulary we will often use in algebra. So what I'd like you guys to do is just pause the video for a second and read through these expressions, these vocabulary words here. All right, well, it always helps to look at some examples. So let's go ahead and do a few examples over here in the margin. Let's start with constant. All right, a constant is a value that doesn't change. So another way to think of this is a number. It says, for example, numbers are constants. In our situation, numbers are constants, period. Okay, a term is a constant or variable or the product. What does that mean? Multiply or quotient, divide of a constant and a variable. So pick any constant, say -6, and then if you put a variable on that like r, that's a term. That means -6 times r. Remember, if there's nothing between the -6 and the r, it means multiplication. I could multiply it by another variable like x. That's still one term, as long as it's being multiplied. I could divide it by some other variable like t. That's still one term because it's all multiplied and divided. If I have a number like a constant like 7, that's a constant. If it's just a constant by itself, it's also a term. Okay, so a term is a constant all by itself, or a variable all by itself. Like if I just say x, that's a term. Or the product or quotient of constants and variables. Okay, so it could be more than one thing. Like this guy right here, 7, that's a constant and a term. X is a variable and a term. This is just a term. It's not a constant or a variable. It's the product, a quotient of constant and variables. An expression, we can add two or more terms together, separated by a plus or minus. So add or subtract. So here I've got some terms that we just went over. Right? This is a term, this is a term, this is a term. So an expression would be adding or subtracting those terms. So let's say I take my first term, which is a 7, and my next term here is an x. If I subtract those, that's an expression. I can add those. That's an expression. Let's say I have another term over here, 4q. So 4q is a term, and the constant 1 is a term, and if I subtract those, I have two terms, and that's an expression. 4q minus 1 is an expression. An equation is where we have two expressions that are equal to each other. So we could take any of these two expressions and put an equal sign between them. So for example, we could take our 7 minus x and set that equal to 4q minus 1. That's an equation. We could take a constant like 7 and set that equal to 4q minus 1. That's an equation. But the deal with an equation is it has to have an equal sign. And then on either side of the equal sign, you're going to find an expression. That expression may have multiple terms. It may have constants like we see here, and it most likely will have variables. So pi is a number that is actually a constant, just a little reminder here, and it uses the symbol like that. It's approximately 3.14159. And actually what it exactly is, you can find pi if you guys want some fun times this weekend. Oops, that's a terrible circle. Let's try a different circle. Let's see if we can insert one here. I think if I hit control, no, that's not a circle. There we go. Hit shift and it makes a circle. Okay, so find a circle in your house and get a tape measure or like a, fabric tape, and measure the distance around that circle. It could be a cup, could be a bowl, could be a ball if you could get it around there. Measure that distance around the circle. That's called the circumference. Whatever number that is, write it down. Then see if you can measure the distance across. Well, that blue doesn't look very good. We'll use pink again. Measure the distance across the circle. That's called the diameter. Now, take those two numbers and take the circumference, your number you got for your circumference, and divide it by the diameter. And the better measuring you did, the closer you're going to come out to 3.14. No matter what circle you started with. That's what pi actually is. Okay, and this is a constant. Even though we represent it by this symbol, it's still a constant, not a variable. Why? Because it's not changing. It's always this number, 3.14159. All right, so to make sense of this terminology, we want to compare and contrast the terminology, and we've used Venn diagrams before, so we're going to do that now. Make a Venn diagram with one circle labeled constant and the other labeled variable. My circles don't have to be perfect for this, so we'll just go like that. So here's all my constants live in this circle, and all my variables live in this circle. So it says decide if the circles will overlap. If you can think of some characteristic that a constant and a variable share, then the circle should overlap. So we have a little overlap here if we can think of something. In each circle, list examples and attributes. So I'm going to start us off here. I'll list a few, but I want you guys to finish this and list some more. So an example of something that's a constant and not a variable is pi. We just talked about that. So that's in the constant circle and not the variable circle. Something that's changing could be the radius of a circle could change. So I'll put r for my variable over here. Now something that a constant and a variable have in common is they are one term. Every constant is one term. Every variable, single variable, is one term. So what I want you guys to do is put a few more things in this area of the Venn diagram. See if you can think of one more thing to put in here that they might have in common. And then a few more examples over here in the variable part. Alright, so now we're going to repeat problem 1 with expressions and equations. So we're going to make a big circle for expressions and a circle for equations. And we always want to label them. So we're going to do the same thing. I'll list one here. I mean, we have some from what we did earlier, like we had the expression 7 minus x. And actually, we talked about how a constant all by itself, how about 0? That's a constant. That expression all by itself is also, this constant is an expression. So an equation, we would have to equal these two things, or equal any two expressions you want. So I want you to think of some more expressions over here and some more equations over here. And maybe what are some things they have in common? What do expressions and equations have in common? We could say that they may contain variables. An expression could have variables, an equation could have variables. Okay, maybe list a couple more things that expressions and equations have in common. So the purpose of this lesson was really just to get some vocabulary under our belt before we get going on some more complicated things. So these are words you definitely want to have in your vocabulary and be able to recognize them and distinguish between what's a constant, a variable, an equation, and an expression. Okay, how do we differentiate between variables and constants? And how do we differentiate or tell the difference between expressions and equations?